Caching common server responses is an easy way to dramatically improve the response times of your server while also reducing pressure on resources such as databases or remote APIs. In this video, we'll implement a caching solution to improve the efficiency of our Mars wallpaper API. If you haven't watched that video, you can check it out here. We'll do a quick recap, so don't worry if you're not up to speed. Last time, we used the Fast API library to implement a web service that allows users to pick a recent photo of Mars from the NASA Curiosity rover and resize it for use as a wallpaper. We implemented two routes, the root route and the wallpaper route. The root route returns the metadata about the available photos, namely the most recent Earth day on which a photo was taken, and the number of photos taken on that day. We used a utility function called getPhotoInfo to query the NASA API and parse out this metadata. The wallpaper route allows the user to specify a photo number of interest as a dynamic path variable, as well as an optional height query parameter which determines the height in pixels of the returned photo. The wallpaper route then queries the NASA API for the photo of interest, resizes it appropriately, and returns it to the user. A major limitation of our web service is that the NASA API must be queried on every single request. This is slow, and many requests to the server could trigger API rate limiting. To remedy this, we'll implement caching in our application using the Cachetools library. Caching works by saving the result of a function call in memory and retrieving the result from the cache whenever the function is called again with the same arguments. We'll first add caching to the getPhotoInfo function. We do this in Cachetools by decorating the function with cached and specifying the caching strategy. The caching strategy determines the maximum number of items that can be stored in the cache and how and when items should be removed from the cache. In our case, we'll use a TTL cache. Since getPhotoInfo will return the same response each day, we only need to cache this one response, so we specify a maximum cache size of 1. The time to live argument specifies the maximum time an item can remain in the cache. Since we know the NASA Mars Photo API updates once per day, we want the output from the cached getPhotoInfo function to only live for a maximum of 1 day. We can now check out the response time of our root route, which just wraps the getPhotoInfo function. The initial response from the root route takes around 900 milliseconds, but querying again only takes 2 milliseconds, a massive speedup. Now, getPhotoInfo will only run at most once per day when the cache is empty. All other times, the response will be returned from the cache. Next, we'll add caching to the wallpaper route. First, we'll refactor the makeWallpaper function by moving the NASA API photo request and resizing logic to a new function called getPhoto. We'll decorate this function with cached, specifying a TTL cache like we did previously. This time, the user can request different photos of different sizes, so getPhoto has multiple possible return values for a given day, unlike getPhotoInfo. So we'll set the maximum cache size to be 64. When a new item is added to a full TTL cache, the least recently used item will be removed to make room. To finish off, we'll call getPhoto in the makeWallpaper function. Checking the response times, we see an initial response takes around 2 seconds, but a follow-up response only takes about 800 milliseconds. And that's all there is to it. It's important to note that for a larger scale production application, Cachetools may not be an appropriate choice. For example, if multiple instances of our Mars wallpaper server are running, each instance will have its own cache rather than a shared cache. A better approach would be to use a solution like Redis or Memcached, which allow multiple processes to use a central cache. Alternatively, static routes such as our API's root route could be cached with a content delivery network such as Cloudflare. For our simple application, however, Cachetools is sufficient and illustrates some basic techniques that can be applied to larger scale implementations and alternative caching solutions. If you want to know more about this pattern, you'd like to discuss it, or you'd like to write your own patterns, check out Patternite. The link is down below. Remember to like and subscribe, and we'll see you next time.